This is the ICO Alert Podcast, Episode 5. I'm your host, Robert Finch, founder of ICO Alert. ICO Alert is the trusted source for analysis of ICOs, otherwise known as initial coin offerings. We maintain a comprehensive list of ICOs on our website at ICOalert.com. If you're new to the ICO space or even the blockchain space, don't worry, we've got you covered. Head to start.icoalert.com, where we have helpful introductions to this exciting new world, introductions about ICOs, and introductions about the blockchain space in general. That's start, START.icoalert.com. My guest today is Peter Waterland, founder of the QRL, the Quantum Resistant Ledger. During the podcast, we'll talk about the QRL project, how quantum computers pose a risk to blockchains, and when quantum computers might be able to perform such an attack. Without further ado, let's get to it. Peter, thanks so much for joining me today.
It's an absolute pleasure, Rob. I'm
Awesome.
very pleased to be on the show.
Yeah, it's great to have you. So QRL, of course, if you all don't know, QRL is sort of an under-the-radar project right now, but they launched an ICO, or rather a pre-sale in May, and it actually hit their funding goal of $4 million by the end of May before their ICO even launched. So very interesting. A lot of people haven't heard of it. But before we dive into your ICO details, I do want to talk about that towards the end of the call. I'd love if you could just give a brief overview of QRL and what it is and the problems it solves for those that aren't aware.
Yeah, thanks, Rob. So the QRL, as the name would suggest, is a quantum resistant ledger, and what we are is a blockchain startup, a public blockchain designed to resist the advances of a quantum computer. And I know you're aware of that threat to the ecosystem, but for your listeners who aren't, quantum computing is probably now for the first time ever becoming a real thing, a real entity. And all the signature schemes which protect pretty much all the existing blockchains out there, Bitcoin, Ethereum, every major chain really that exists, relies upon, for account security, it relies upon ECDSA, elliptic curve cryptography. And a quantum computer that's suitably powerful can easily break that. And by break it, I mean they can reverse a public key to get a private key and spend funds that previously were completely secure against any form of competing attack. And so what our project is about building a very, very secure public blockchain where that's not a possibility. And so there's a few aspects to that in our project, and I guess the most important is that we use a post-quantum secure signature scheme called XMSS to protect all our accounts. And that's very different to the existing systems, because it's a hash-based signature scheme, which is stateful and is very, very different, very alien compared to sort of existing schemes for coins like Bitcoin and Ethereum.
Yeah, could we take a second just to break it down? I know there are a lot of sort of terms flying around, like with XMSS and signature schemes and stateful. Could you kind of break down what that means for everybody?
Absolutely. So I suppose everyone who uses cryptocurrency should know that their funds are held in an address, and that address is an address that only you should keep the private key for. And by convention, in order to spend funds, you need to have the private key to sign the transaction. And if you don't have the private key, you can't sign the transaction, you can't move funds. So cryptography basically backs all of cryptocurrency so far, and it's why it's so elegant and so beautiful a construction. And what Bitcoin started with, that idea of using public key cryptography to protect funds, and combining it with distributed ledger, the blockchain, was remarkable, absolutely remarkable advancement. But that earliest point, protecting your address with a private key which only you have control of, is at the moment is very secure. It's unbreakable with current technology, but in the coming years, there will exist a computing platform called the quantum computer, which is able to do the unthinkable and break that cryptography by being very clever.
Wow.
Say again?
I was just saying, wow. So essentially, This would allow anybody, assuming they have access to a quantum computer, to essentially gain access to your funds that you stored in a private key, or excuse me, in an address that's secured by a private key on Bitcoin or Ethereum or these blockchains. Is that correct?
So the way it works now, if you send funds to a cold storage address, if you haven't used that address, then there's no way anyone ever can get access to it. Even with a quantum computer, they can't get access to it. But as soon as you spend funds from that address, by spending the funds, the public key to that address goes with the transaction and is stored in the blockchain. And then from that moment on, that address is vulnerable. And so a really simple way to protect all of cryptocurrency, all the major chains will be to not allow people to spend more than once from each address. But obviously that's very cumbersome, and it doesn't really work particularly well with money. The idea you've got to move all your money every single time you spend it is a challenge. And so because people are people, I think last time I checked, is about half of all Bitcoin addresses have been spent from before, so that their public keys have been exposed. So a clever person could wait until the technology advances and then go back and begin harvesting those addresses. And that's true for any Bitcoin or Ethereum address, which is vulnerable, which has been used. So this is a really real thing. Now, the big question is, when is this actually going to happen? And that's the question no one can really answer. We're certainly not there yet. And myself and John Paul, someone else from the team, one of the other core developers, we went to a conference in Germany last month, hosted by Blue Yard, a quantum fund, and looking really at the state of the art in the quantum computing world. And it was attended by all the major quantum computing startups. There's representatives from Google, IBM, every major QC company out there, and there's a lot of money behind this drive, because they're getting close now.
Yeah, and how close do you think they are? I'm sure being able to listen to a lot of the panelists at that conference, titled A Quantum Leap, would probably give you a decent look at sort of the state of the industry. I mean, how close do you personally think we are? Are we a few years, a few months? What do you think?
Oh, I think we're a few years away, for sure. But I mean, one thing is difficult. I mean, Google talk about quantum supremacy, this idea of building a commercial computer which can perform a certain task by the end of this year, in a commercial setting. So that's not far away, but there's certainly a few major engineering obstacles to overcome before they can build an error-corrected, universal or quantum computer suitable, to break ECDSA. I mean, that's probably years away, being honest about it. But what we don't know is, what else is going on out there in the world, and there's other major interests who have a lot of funds which can be spent to pursue this goal. So I think if tech's taught us anything, it's that these advances tend to be fairly non-linear when they come, and if there's lots of people chasing the next big thing, then we don't really know what's around the corner. And so, yeah, the QRL is all about being ahead of the curve, really, and building something that people can put their money in and be absolutely sure that it will be secure for now and for.
So just to touch on that piece about Google, are you saying that they'll have a commercial quantum computer by the end of the year? That's what they claim. So theoretically, when you say commercial, do you mean something that would be sold to consumers, or is it something else?
Great question. You'd have to revert back to the exact presentation from Google, but they talk about a roadmap, and on their roadmap is this idea of Google of quantum supremacy. And I mean, they were saying openly at the conference that they have a computer capable of working to 49 qubits, which is commercial grade already. It's just not. These are prototypes.
Yeah, could you explain for people what a qubit is? Because right now I know in the current state of computing, it's very different, where we have bits, things that are essentially a 1 or a 0, a yes or a no, and that's how data is stored using electrons. But I think the general public, and probably a lot of people listening to this podcast, have no idea what a qubit is or how a quantum computer functions. So if you could explain that, that'd be great.
Well, I can try, but I'll preface this by saying that I've got an interest in blockchain and in cryptography, but I'm not a quantum physicist. So first thing to say is that conventional computers don't work in a totally different way to the way a quantum computer works. So quantum computers are made up of qubits, and it's my understanding that each qubit is also known as a gate, and each qubit, unlike a conventional binary 1 or a 0, that they can be 1 or 0 or any position in between. And by linking lots of gates of qubits together, and by using clever quantum algorithms, it's possible to perform many calculations in sort of one step, whereas conventional computers tend to work over a problem by iterating over it. And you may have many different cores within your CPU, so your computer may be able to do many things at once, but it may have 16 cores, and it may have many different execution lines, but it can't do things in a massively parallel way. Whereas a quantum computer can do things in a massively parallel way. It can't do anything, and it is limited by physics, but it does completely change the way that computing works. And it's a shame actually that we haven't got Leon here to discuss it with you, because he is actually the brains, the cryptography brains, and the quantum brains in the project.
Oh, okay.
And that's our cryptographer, because he can go on about it endlessly. But the short version is that the quantum computer can do in sort of one step, sort of infinite number of permutations based on the number of qubits in the machine. So the more qubits there are, the more powerful the computer is. And so at the moment we're talking about 20 to 49 qubits, which is what these computers can do. But realistically, to get to a point where conventional signature schemes are vulnerable, it needs to be probably at least 1,500 qubits. So it's a fair distance to go. But as I say, there's about 5 or 6 different quantum computing startups that have got very different ways of going about it. So a breakthrough could come at any moment, and that's the exciting thing about it.
It's fascinating. I mean, it seems that there are a lot of parallels between quantum computers now and how they're sort of maintained or stored, and computers, like traditional computers back in the day when they were sort of first being developed. And what I mean by that is, one of the interesting things about quantum computers is you have to store them at an incredibly low temperature. It's like negative 400 degrees Fahrenheit or something like that. And, back in the day when computers were these massive things and they're in these air-conditioned temperature control rooms, it seems like there's an interesting parallel there. Do you think that those problems can actually be solved? Like, will quantum computers in the future, when they're commercial grade, will they still have to be, will they still have to maintain a certain temperature to keep the qubits in that quantum state? And maybe speaking about this from sort of a naive or elementary perspective, so please correct me if anything I'm saying is inaccurate. But do you think that's possible? Like, is that physically possible to make a quantum computer that doesn't require a certain temperature to function?
That's a great question. I'm certainly, what I would say is that at the moment, from what I can see, every single one of these designs, apart from perhaps using optics and photons, does require that. So that is obviously a major limitation. But I mean, no one is suggesting that a quantum computer is going to replace your desktop or your laptop. But actually, what is fascinating is what you said about it being like the early days, from when conventional computers first came into existence, microprocessors. There was quite a lot of grisly old guys there who were there at that time, and they were saying that this is the same. They get the same feeling from this, that this quantum revolution that's coming is exactly the same, and that we are very early on that curve. But it's funny. I sat there with John Paul's developer from the team, and we got a real sense in the room that something incredible is coming in the next few years. And there's that magic word from Silicon Valley, disruption. I think there's going to be a lot of disruption from these machines when they start to really become commercialized and outperform conventional hardware. But I take your point, that it's a non-trivial task, and it's taken 20 years to get to this point. So there are obviously massive engineering complexities around building these machines.
Absolutely.
And as you say, they need to be super cool at the moment. So it's not something that's going to be on wristwatch.
Yeah, and I'm sure that people had the same thought about, the computers that we're using now. Like if you had told somebody 20 years ago that eventually they would have a computer that's orders of magnitude more powerful than the giant computer that took up an entire research center, that they would have that in their pocket and be able to communicate with anyone else on the other side of the planet at any time, I mean, they would tell you that you were insane. So perhaps we'll see something similar with quantum computing where somebody, like you're saying, has a breakthrough and sort of enables that technology to reach the masses. But it will certainly be fascinating to see.
It'd be fascinating, and I think it's one of those black swans, like the internet and telecommunications. I think it's probably one of the next big things to break through. But like all these things, timing is everything, and it's impossible to give you a firm timeline on when that's going to be. All we can do is be prepared, and that's what our project's all about: being prepared.
Absolutely, yeah. And could you talk a little bit more about being prepared, where somebody would theoretically be able to attack one of these blockchains and start brute forcing essentially private keys in a way by just reversing the public key and gaining access to people's funds? What would be the, and speaking from a theoretical perspective, what would be the incentive for somebody to do that? Because essentially once they do that to one or two or three keys and they continue to steal people's funds and people find out about it, one would expect the price of that particular asset, whether it's Bitcoin or Ethereum, to totally go to zero because people realize that they can't securely store their funds anymore. So what would be the incentive for somebody to try to steal that money if them stealing it and sort of performing that act would render what they just stole worthless?
I think there's numerous reasons why. I mean, that's a very wide question. I mean, the first thing to say is that cryptocurrency has a lot of enemies. I mean, it's just going through its latest expansion, but it is a threat to the legacy banking world. So there's a lot of entities around the world, I would suggest, who would like to see cryptocurrency fail. That's the first thing. So not everyone in the world is nice, and not everyone with access to state sort of level resources is a good player. But the second thing you said, stands out, which is, why would you want to attack something and send the price to zero? Well, I mean, as I'm sure you know, speculators make money with the price falling as well as rising, and that would be probably the most incredible short position to take of all time.
Yeah, that's a great point. That's a great point.
But the other thing is, I think it would be something you could probably get away with it for a long time. There's a lot of Bitcoin out there that hasn't moved for a very long time, and I think it would take a while, really, if before people caught on. You'd probably have a series. It's about how this thing sort of unravels in the end. Whether it's orderly or disorderly. If it's disorderly and there's a bad actor there, then it's going to be a bad space for some time. I mean, if there's a sudden emergence of an error-corrected universal quantum computer that comes into existence, or is at least within a few weeks of coming to existence, then all hell will break loose in the space, and there'll be incredible volatility in the cryptocurrency space. And I mean, it doesn't really bear thinking. I mean, I'm a holder of Ethereum, I'm a holder of Bitcoin, so I don't want that to happen. But it doesn't really bear thinking about. You can't just stop the chain and restart it, because as soon as that kind of technology exists and is out there, there's very little you can do to protect the chain.
Absolutely. And going back to what you said about, a bad actor, I tend to agree with you that, it would more than likely be somebody in either the legacy banking institution or perhaps even more likely a government around the world that sees it as sort of a threat to their control of the money supply. As a result, sort of control over certain aspects of society. One thing I wanted to talk about that I don't think a lot of people know is that the QRL is sort of more than just a blockchain, to store value and to be this value transfer layer. It seems that you're also building in a messaging protocol into this, which is fascinating for me, particularly because it seems that the NSA, the National Security Agency in the United States, has a 0-day exploit into virtually every operating system in the world. So a 0-day exploit essentially means that they have an exploit that they found on day 0 before the platform was launched, and they can essentially gain access to that platform and bypass a lot of apps that use encryption. So as an example, like Telegram, the app on iOS, which says that all their messages are encrypted, that may be the case, but the NSA can also theoretically access those messages before they're encrypted or before they're sent. So if you could talk a little bit more about that messaging layer of QRL, how is that integrated, and will that also be quantum secure?
Yeah, that's a great question, and and I have to say, I think we probably agree on a lot of things because privacy is something which has really disappeared in recent years. So you're absolutely right. The primary sort of focus on our launch is going to be value transfer and and value storage. But much like Ethereum has its Whisper layer, we're building a messaging layer called Ephemeral. That's what we've called it. And one of the really powerful things about a blockchain is it allows you to store data and store data in a way where you can associate data with a particular address and use that address as a cryptographic identifier, so as a form of ID. So if you think about it, you can create an address on, say, the QRL blockchain, and that can be sort of a dial-up address for another node on any device anywhere in the world that can access the QRL network. Can theoretically, if you could build a data channel between the two that was private, you could create a completely secure end-to-end data channel from one address to another address using the blockchain, but also allowing sort of abstracted communication above the blockchain. So we decided quite early on, actually, as a result of some discussions, that this is a really fascinating thing that we could build, and we think we've got a great design for it. So what we have is a system where we basically use the blockchain to put special transactions which contain a couple of lattice-based cryptographic public keys, and then we basically use those as sort of finder marker transactions which link one end of the channel to a particular address, and only the person making the transaction has the lattice-based private keys for that address. But anyone can send information to that address from any other address on the chain. And we have a sort of secondary layer that runs, and we call it ephemeral because the messages aren't stored anywhere. We have a sort of broadcast messaging layer that runs above the blockchain, which allows communication in a special way, where we use something called a pseudo-random number function seed. Okay, let's go back. So
yeah, there are a lot of complex terms being thrown out again, and well,
basically, we use public key cryptography to encrypt a message from one person at one end of the channel to the other end of the channel, and only the person who has the private key, which is linked to the blockchain address, is able to decrypt that, and that message comes in a verifiable way from someone else with an XMSS address on the QRL. So Alice and Bob open their channel to each other, and within that first message is a seed which is used to generate a very long sequence of numbers, which become the IDs for the messages that then are subsequently transmitted back and forth between them. And it also contains a key which allows symmetrical data encryption between the two, and then. So
it's basically it's basically a way of being able to send a message to someone incredibly securely, where you're encrypting it, and then only that person can access that message because the message technically isn't stored anywhere. Correct?
Correct. And actually, we in answer to your second question, is it post-quantum secure? The answer is yes, because we're using lattice-based crypto, which is a different form of cryptography, which Leon's very, very familiar with. And we're using that as our encryption decryption system.
Okay, so lattice-based is just kind of like a new form of, or rather not new, but a different form of math compared to elliptic curve cryptography.
Exactly, okay. and it's probably not. There seem to be many different algorithms over the last few years, but we're using a couple of the later ones, Frodo and Tesla, which I don't profess to know a lot about lattice-based cryptography, but say Leon, our cryptographer, does, and that seems to be the state of the art at present. And so we're planning to use that at both ends of our data channels, and then our plan for the next few months is we'll launch the network, but also we're planning to build some libraries that allow apps and web-enabled devices to connect through the cloud, through the internet, onto the QRL network, and sort of use the QRL as a sort of address book, if you will, to allow completely secure, private, post-quantum secure end-to-end communication.
Wow.
And it's not necessarily communication; it can be data, it can be anything. So you can sort of imagine that that you use this little handshake, this little message passing handshake, to sort of create an IP to an IP completely secure connection for data transfer or communication or VoIP or anything. So it's quite versatile, and that's probably if you ask me, that's probably the most exciting thing about our project, is building that. But at the moment, we're really focusing on our proof of stake algorithm. So although we've actually designed the protocol, and we actually have some sort of placeholder code there.
Yeah, and let's just take a second, but before we jump into the mainnet, because I do want to talk about that and when you think it's going to launch, and sort of your ICO structure of using an Ethereum placeholder token, an ERC20 token. But to sort of unpack that concept of allowing anybody with an app or any sort of other application, whether it's a decentralized application or a traditional application, to link into the QRL and use that as the messaging layer that's completely secure. I mean, that to me is totally fascinating. Will that be something that's available right away? Or are you working with people to integrate that? Could you give us a little more info on that?
Yeah, so actually the nuts and bolts of it is actually fairly straightforward. I mean, and that, if you look at Ethereum, there's quite a lot of apps coming to existence which plan to use the Whisper layer on Ethereum. So I don't think what we're doing is particularly groundbreaking in terms of technical proficiency or difficulty, but what is groundbreaking is the idea that you combine a messaging layer and a blockchain layer together. I think that's the really powerful idea. And in our particular case, we're using post-quantum secure signature schemes based on a post-quantum secure blockchain. So I think if you really care about security, you can't get much more secure than that. So that I'm really excited about that. And the question is it going to be ready for when we launch? I think we'll have something ready, but I suspect when we first launch, it'll be probably confined to node sort of communication initially using our implementation of the Node software. We've got a few got quite a tight schedule to get round, and we have to be realistic about what we can achieve in the next 2 to 3 months. And I think we'll ship with something. But I think that'll be something that comes out a little bit more, certainly with expansion out to allow abstraction out to apps and web-enabled devices. I think that's going to be something that comes in the folling months.
Okay.
But certainly we have. It's funny you say, have you had any interest, or we have had interest from other people in the space, and I'm not going to say any names or disclose any companies, but we have had people approach us about it, because I think it is quite an exciting idea, and for certainly things like corporate, completely private end-to-end communication, is a powerful idea, and people have an interest in that. So I think that could be one of the more exciting aspects of our project in the next 6 to 9 months.
Absolutely. So talking about timeline, then you mentioned 2 to 3 months as kind of your ship timeline. Is that really when you expect to launch the mainnet?
It is at the moment. I mean, we've had the funny thing is that we've had a proof of concept node that's been working since probably about November last year, and that's gradually been sort of changed and upgraded, and it's obviously we've done our pre-sale. We've raised funds now to completely professionalize the development process, and so that code base is kind of what's on GitHub is kind of on ice now, and we are in the process of completely overhauling that code base and making it security grade and building up to be enterprise grade, really secure, high quality software. And that's a non-trivial task, but the short answer is it'll be ready when it's ready. But we're hoping certainly to have our testnet back up using our final proof of stake algorithm in the next 2 weeks. That's our current aim. And really, Rob, it depends on how much testing we have to do to be happy that it's working. I mean, one thing that's great about launching the ERC20 tokens is that we've gone from having just a handful of people on our Slack to having, I think, over 1,1400, I think, last time I checked. And that gives us a fantastic pool of alpha testers and people who are very keen and found the project very exciting. So I think we'll be able to really ramp up our testing process over the next 2 months.
Yeah, that's great. Let's talk about that a little bit, the ERC20 token. So for those that aren't familiar, an ERC20 token is an Ethereum token, essentially. It's a token that you build on top of Ethereum as a network, and you pay Ether to essentially transfer that token to other people. So QRL is very interesting in that they used the ERC20 token as a placeholder token, which will be convertible to the actual Quanta token once their main network launches. And I'm really curious to know the reasoning behind it. I mean, did you launch this placeholder token, which obviously I think has been very successful for you, both in terms of your market capitalization, but also, like you're saying, with community engagement on your Slack? Was that really your goal for this, to sort of get more people, get more eyes on your project, get more people sort of in the know about it?
No, I mean, it's really funny actually, because we're a fairly small team and we're all remote, but actually the team, I think we viewed ourselves as a kind of unique project in the space, and all about the tech, all about the premise of the project. And actually, it was actually the people who were coming to us, putting in funds for the pre-sale, who asked us specifically to consider this. And at first we were sort of a bit dismissive of it, but then it became clear that almost everyone who was putting in funds wanted us to do it, and it did make sense to me that it would certainly raise our profile. It certainly raised the pressure, because we raised $4 million in our pre-sale, which will cover our development funds, and that's what we wanted to raise. But as soon as we launched on the Ethereum mainnet with the ERC20 token, and as soon as we went on exchanges, our market cap went from 4 million to what it is now, many fold higher, and I think we jumped straight into the top 50 to 70 on the Coin Market site, which was incredible. None of us expected that, and it certainly turned the pressure up.
Yeah, I'm sure. I mean, it's totally different when you're sort of working in this, low key, low profile environment, and then to be thrust out in front of the community, and people are suddenly, relying on the team in a way to accomplish the goals in order for them to receive some sort of financial return. So I'm sure it's totally changed the dynamic. Do you think that it's changed the dynamic with the team in any negative way, or do you think it's only made you all work even harder?
I think it's definitely made us work harder. So that's I think that's a positive thing. It's there's nothing more that sharpens your focus than 1,000 people wanting to know what's happening with the project.
Right. Yeah.
But the great thing about it is that we were very, very under the radar. We didn't really promote ourselves except for sort of registering with a few sites, your site in particular. We didn't really do much more than that. To be honest with you, in terms of PR, and
wow.
We basically let the project sell itself, and we had no idea really how much we were going to raise with the pre-sale. And so we actually set different scenarios, what we could fund with the developers based on how much we took. And I think I don't know whether it's because we raised this money in the middle of the sort of this great crypto expansion of 2017, or whether people were really enamored with the idea that what we're building is potentially revolutionary. But
I think it might be, to be honest, I think it might be, just to respond to that, a little bit of both. But I think primarily it has to do with the concept, because, looking back at my sort of like crypto career, if you want to call it that, first discovering Bitcoin in 2012, one of the sort of existential threats to cryptocurrency that I always viewed, and that I would have long discussions with my brother about, was quantum computing. So to see QRL pop up and sort of start to address those potential problems and those potential challenges was really fascinating to me. And I'm sure a lot of the other members of the community sort of had that same resonance with your project.
Well, I think some of them must have.
Yeah, absolutely.
Absolutely right. And I think, if nothing else, I think we will certainly be, a good, strong, ultra secure public chain. But I think, if nothing else, we will show that it's possible to do this in the crypto space, and I think be a beacon, hopefully, for the rest of the industry to follow on as things get a bit closer to the wire. But back to your original question.
Yeah.
are there any positives? I think so. That what you said is absolutely right. There were lots of positives. I mean, we basically have a very, very, very large community now compared to how it was only a few weeks ago, which is brilliant. So many people who are very, very enthusiastic and almost passionate about the project on the Slack, and actually, it's brought a lot of good technical people to us as well, from not just programmers, but people in every sort of in lots of different disciplines have come to the Slack and offered their services. So it's been absolutely fantastic from that point of view. Are there any negatives? I mean, there are negatives. I mean, probably the most worrying thing is that we have no control over the price of this token, and it's before it was kind of it was my project. I started it off, and then I've got the rest of the team have joined the project, and we're a strong team now, very cohesive, strong team. But it was kind of our baby, and we were building what we were building. But now what we do, potentially echoes in the market price of the token, and when the price goes up, that's fantastic. Everyone's happy. When the price goes down, we feel a bit helpless because it's out of our control. But we just have to get on with it, I think, and stick to our guns and follow our roadmap as best we can. I think everything will.
Yeah, one of the things I wanted to talk about, sort of jumping back to the very beginning of the conversation, was you mentioned, a quantum attack really couldn't happen to a Bitcoin address if you sent funds to that address once and you never sent from that address. But once you send a transaction from that address, the public key sort of goes out with that transaction. And because of that, you can reverse the the public key to discover the private key, which unlocks those funds using a quantum computer. And you mentioned, an easy fix for this, of course, or I guess relatively easy, because I'm not sure it's really that easy, would be to just make it so that everybody has to use a new address for every transaction. Do you think that there's something like, is there another solution to that might be a quick fix for this that existing blockchains could implement? Like, could they obscure that public key in some way when a transaction is sent, or does that just totally undo? Is that a core function of the way that these protocols work?
Yeah, I think that's a great question. I mean, there probably are. There's many ways to skin a cat, and there probably are some tricks you can do. But I think it's a fairly critical point to me personally, anyway, of Bitcoin and Ethereum is that it should be that only the person with the private key is able to sign a transaction, and that is the transaction. I think if you start adding layers of abstraction, then it ceases to be the pure Bitcoin that I'm sure you did, similarly to you in 2012. I came across it late 2012, and it blew me away. The elegance and beauty of it, and how powerful yet simple it was. There may well be fixes, and I'm sure there probably are some fixes you can do, but I don't think they're going to be anything more than a simple stopgap.
Interesting.
To some put in.
Yeah, because I think that's sort of gauging community interest around QRL, and also as I'm looking through forums on Reddit and different posts on the QRL Slack and things like that, it seems to me that the main question the community has is the QRL is great. It really sort of ahead of time, which I think is the way these things should be addressed. It addresses this huge issue of quantum resistance and the rise of quantum computers. But what most people are sort of curious about is how easy is it for an existing blockchain like Bitcoin or Ethereum to implement quantum resistance, and doesn't that then in effect sort of make QRL obsolete?
Yeah, it's a great question, and it's one we hear a lot, especially with Ethereum moving forward with their account abstraction in their roadmap. But I mean, there's a few things to say. I mean, the first thing to say is that if you have a blockchain that's got sort of mixed address types, where some are quantum safe and some are not quantum safe, then if there is a nonlinear black swan advance, or even just the rumors of a black swan, then that will create massive volatility in the price indexes of the various blockchains. Just the threat of it will do that. If it actually occurs and just appears one day, then it doesn't really matter if if half your blockchain is insecure and half of it's secure, then unless you freeze half of it completely and remove all those users' funds from access, then the value of the token will still go down to zero. Even if I would actually say that even if 10% of your blockchain is insecure, is kept in legacy addresses, then as soon as a QC arrives that is able to plunder those addresses, the value of the blockchain token will go to zero, because that's how markets work.
Yeah, absolutely. I mean, so when you're referring to like half and half being quantum resistant and half not, is that referring to the Ethereum implementation?
Absolutely. I mean, I actually don't know quite how far they are along with that. I probably should look into that a bit more. But I know that Vitalik was planning on creating some abstraction with one of their EIPs, which would potentially allow some form of quantum safe address to be created and used. I mean, what's interesting about quantum safe addresses, and this XMSS, Extended Merkle signature scheme system we use for the QRL, is that it's a stateful signature scheme, and what that means is you kind of have to know what's gone before. And in that respect, the blockchain is fantastic, because the whole history of every transaction is there for everyone to see. But you have to know which keys have been used already and which keys haven't been used. Otherwise, the signature scheme itself is insecure. I think that's probably a non-trivial thing to build into Ethereum and Bitcoin, especially if you want to think about things like pruning and and sharding and all these things for scaling. If you're using a stateful signature scheme like we are, which is the state of the art in terms of post-quantum security. So I'm very curious to see what Ethereum builds actually, and what they ship and when they ship the Metropolis hard fork, whether it actually does contain that or not. And I hope it does, but I'm very curious to see how they go with that.
But to talk about this specifically, I mean, why why sort of build QRL and go through the trouble of building this entirely new blockchain if you think Ethereum and Bitcoin could sort of implement this relatively easily, or with a Metropolis hard fork or something like that? Like, why not take your talent and your team's talent and sort of apply that to existing blockchains? Why did you feel the need to build your own?
I mean, that's a fantastic question. Actually, when I first came up with the idea last year, I did actually communicate with Vitalik on Reddit about the project, and he did suggest at that stage that I engage with the Ethereum process.
Wow.
But what I would say to that is that I would allude back to our original my original point, which is that blockchain should be about security. I mean, Bitcoin, when it first came out, it's absolutely groundbreaking. It's this unbreakable, completely ungameable, elegant solution to cryptographic money. Incredible thing. Yet it has this enormous vulnerability there, waiting to erupt and dismantle it. Now, Ethereum may eventually create some form of quantum safe address, but people aren't going to use it because it's not going to be particularly easy to use it. I mean, I give a simple example from our wallet software. Creating one address using our system, using XMSS, creating one address with 5,000 signatures in it, takes about 55 megabytes up in wallet space. So,
oh, wow.
Exactly. So it's totally different way of looking at keys and addresses. My original point was that I think security is the most important thing of all when it comes to blockchain and ledgers like Bitcoin and the big ledgers going forward. You've got to be able to provide security, and I just don't believe and didn't believe that anyone in the space is really taking this seriously at all. I looked around, and there's another project called IOTA, which has some form of quantum resistance because they're using a one-time signature, which is what we use, the Winternet signature, for their transactions. So they've got a little bit of quantum resistance in their system, although they're not a blockchain. But no one else in the space, not a single project was even looking at it 12 months ago. And John Paul and I were sat in this conference. We're the only startup there, only tech startup there, but pretty much all hardware and quantum firms there. And it became abundantly clear as we were sat there that we're on the cusp of a revolution here, and you just have to look at how long it's taken Bitcoin to not scale in the last 3 years to see what is it going to take for these monolithic giant chains who've got very how can I put it, frozen development programs. What's it going to take for them to actually move and move forward and make major changes that need to be made? I suppose Ethereum is, as in most things, it's trying to eat up the space, and it's made a move in that direction. But even Ethereum will only potentially offer the option of a quantum safe address. That doesn't mean that the chain is secure. In fact, it means it's no more secure than a chain that doesn't have any quantum safe addresses, really. And unless everyone is using them, the chain is secure. So that's why I wanted to build it, really, to try and build something that's completely secure. And I've been absolutely fascinated by the space. I'm sure you have. I don't know. You kind of get sucked into blockchain, and you get sucked into Bitcoin.
Yeah.
And I saw an opportunity to build something really unique and exciting, and I took it.
Yeah, no, I think that's a great answer. I mean, going back to your point about, Bitcoin and sort of the politicized nature of it, I think, while it may be relatively easy from a technical standpoint to sort of, be quantum resistant to some degree, I think this whole contentious hard fork situation that's happening right now with the Bitcoin scaling issue, like, should we increase the block size? Should we not? How should we do it if we do? I think that sort of proves that implementing any kind of change to any of these existing blockchains will be more difficult than people expect, just because it's so difficult now and has been in the past. With the Bitcoin scaling debate, for example, going on for years, and now it appears finally we might come to some resolution, even though it may be a temporary resolution in August. So to talk about IOTA, we're talking about your competition with Bitcoin or Ethereum and them implementing some kind of quantum resistance. IOTA you mentioned earlier, and IOTA is not a blockchain, it's a tangle. So for people who aren't familiar, a tangle essentially functions not as a series of blocks, but it functions in a way that when you make a transaction, when you post a transaction to the network, in order for your transaction to be confirmed, you must confirm 2 other transactions. So you end up with this long tangle of transactions that are sort of confirming other transactions. And the nature of this tangle is that it's effectively infinitely scalable, because as more and more people are using the network, the more efficient and more fast the network becomes. But if you could talk a little bit about IOTA and how they're quantum resistant. I know there's been some sort of criticism in the community around it and whether or not they're quantum resistant, because there aren't a tremendous amount of details available about the quantum resistance. But if you could talk about that, I mean, do you think that they are quantum resistant?
Well, first of all, I should say that I think IOTA is a really fantastic, innovative project. It's probably one of the first projects in the space for a while that I've really looked at it and thought, this is brilliant. Really interesting. I mean, the white paper is a bit hard to get through, but it's a great project. And I think the team seem very professional, and I think they're building something great. What I would say is that they definitely are quantum resistant in the sense that their signature scheme for their addresses is based on precisely what we're using at the very lowest part of our signature scheme. So in the QRL, you have, let's say you have an address where you put your funds, and with our system, you choose the number of signatures you want to have in that address, and then the size of your wallet file will depend on the number of signatures which you're able to make from that particular address, which is used to generate that many for every single time you want to make a transaction. You create a public key and a private key pair, something called a Wintonits OTS plus key pair, and that sort of smaller unit, which we then put into a giant Merkle tree and then condense down to form our public keys and then our addresses. That smallest unit is what also powers IOTA, I believe. So because that is a hash-based, very, very, very simple thing, very hash-based signature, then yes, by definition, as long as their cryptographic hash function is sufficiently powerful to be able to withstand a quantum attack following Grover's algorithm, then yes, it is quantum resistant. I would say.
Okay, very interesting. Yeah, because I know the sort of general consensus of the community, or a lot of the concerns that people had, were just that really they didn't have any explanation of how it was quantum resistant in their white paper and their sort of project overview. It just was this like little tacked on point at the end, like, oh, by the way, we're quantum resistant, which I think people sort of threw up, and rightfully so, threw up red flags. But it's always interesting to get somebody, you know, who's more familiar with the space and to sort of validate that. And I think, you know, IOTA has taken steps now to address it as well. But it's very interesting.
Yeah, I mean, I think the most interesting thing about it is actually not the fact they're using this one-time signature, but actually the DAG, you know, the Tangle. I mean, that it's I need to read more about it actually, because it's as I say, it's the first project which isn't a conventional blockchain to enter the space for some time, which has the potential to disrupt the space. So. It's pretty exciting, actually.
Yeah, absolutely. It was pretty fascinating to me. When I heard Tangle, I assumed it was just some new buzzword for their blockchain. And then when I did a little more digging and realized, wow, this is a totally new way of sort of maintaining a distributed ledger, it's a pretty fascinating project. I mean, do you see any, and maybe there is no synergy here, do you see any potential collaboration between you and IOTA, or any synergy there?
Well, I think it has to be. That's something we're going to need to look into. I mean, I'm open to collaboration with anyone in the space who's going to be beneficial. You know, where it's beneficial for both parties. I think there's an element in the crypto space of competition between different projects. But I think if the last few years have shown anything, it's that different chains come out which have different functions. So you got Monero, which offers privacy, and then Zcash comes along, which also offers privacy. They're both excellent solutions to that problem, and they both coexist very peacefully. So I think there can be more than one project in the space that offers similar attributes and protections. But yeah, I'd be very open to collaborate with them if we could find that in a mutually beneficial way. Yeah, fantastic.
That's awesome. Yeah, I think that's a really good point too about sort of this competitive aspect. Like there's this whole war with some members of the community, if I could call it a war between Bitcoin and Ethereum, and the flippening, and Ethereum's going to overtake the market cap of Bitcoin, where I think, sometimes there's a fundamental misunderstanding that potentially the two platforms could coexist and potentially even offer two totally different value adds, Bitcoin being more of a store of value and Ethereum being this sort of platform for accessing distributed computing power. So it's always good to hear, it seems that the creators in the space, you especially with that comment, always sort of like to work together with everybody else. And I think that's a great sentiment because sort of a rising tide rises all boats. So that's great to hear. But I think that's probably a good place to stop. If you have anything you'd like to add, that we didn't cover about QRL, and if you could also tell the audience where they can learn more about it, that'd be fantastic.
Yeah, so probably the best place for people who want to get involved or to find out more about the project is to go to the QRL.org, and that's our webpage. It's pretty Spartan, but it does give links to GitHub and to our white paper and to our Slack, where pretty much around the clock. There's the whole team's remote, so we've got people all around the world. There's usually someone awake to have a chat to you if you come on. So we'd love to chat to you about the project, and hopefully we can meet as many of you as possible.
Awesome. That sounds great. So the QRL.org, everybody, if you're interested, go learn more about the quantum resistant ledger. Peter, thanks so much for joining me. It's been great chatting with you, and best of luck with the mainnet launch.
Thank you very much, Rob.
Thank you so much for listening to this podcast. I sincerely appreciate it. If you'd like to request someone to be on the podcast, tweet us at ICO Alert and let us know. We're trying to cover all the ICOs. That includes past ICOs, present ICOs, and ICOs that are, of course, happening in the future. Thank you again, and if you haven't already, please do subscribe to get updates when we publish a new episode. Also, don't forget to check out ICOalert.com for our in-depth analysis of upcoming ICOs, as well as our comprehensive list of every initial coin offering. I'm your host, Robert Finch, and I'll be back next week or sooner with a brand new episode.